Okay, to start out with section 4.1, our first example is find the critical points of f of x equals 2x to the third minus 3x squared minus 36x. So in order to find the critical points, you have to take the first derivative and set the first derivative equal to 0. So to take the derivative of this, we have f prime of x equals 6x squared minus 6x minus 36. And so then we set this equal to 0. So we have 0 equals 6x squared minus 6x minus 36. And so we can pull a 6 out of this. So it's 0 equals 6x squared minus x minus 6. So then we can factor this into two different polynomials. So we have 0 equals 6 times the quantity x minus 3 times the quantity x plus 2. So when we set all these different parts equal to 0, 6 divided by 0 is 0. X minus 3 equals 0 is x equals 3. So that's our first critical point. And then 0 equals x plus 2 is minus 2. So we have our critical points are 3 and negative 2. Then the second example we have is f of x equals x plus 1 over x within the domain of 0.2 to 4. So again, we're going to take the first derivative, but first I'm going to rewrite this a little bit just so it's easier to find the derivative. So we're going to do f of x equals x plus x to the negative first, just to give x an exponent. And then when we find the derivative, we have f prime of x is equal to 1 minus x to the negative second. And then what we're going to do is we're going to make it easier to find the critical points when setting it equal to 0. So what we're going to do is f prime of x is equal to 1 minus 1 over x squared. And we want to make this one fraction, so it's easier to set equal to 0. So then we're going to make this into a fraction. So we have f prime of x equals, and then multiply both the numerator and the denominator by x squared. So you have x squared over x squared minus 1 over x squared. And we can combine this into one fraction. So it's f prime of x equals x squared minus 1 all over x squared. And then we can factor this to the numerator. So we have f prime of x is equal to x plus 1 times the quantity x minus 1 all over x squared. And when finding the critical points, you only need to set the top equal to 0. So we can set each of these equal to 0. So you have 0 equals x plus 1, and 0 equals x minus 1. And when we do this, we get x equals negative 1 and x equals 1. And so when we look back at our domain, it's 0.2 to 4. So only one of these points fits within that domain. So x equals minus 1 is not a critical point. And then we also need to test these because in this question, we're using the critical points to find the minimum and maximum. So we're going to test all three of the points. So we have x equals 1, x equals 0.2, and x equals 4. So when we plug in x equals 1 into the original equation to find the y coordinate, we get f of 1 equals 1 plus 1 over 1. And so this equals 2. And then we plug in f of 0.2 into 1 plus 1 over 0.2. F of 0.2 equals 5.2. And finally, with x equals 4, we have f of 4 equals 4 plus, oh, this one is actually 0.2. I messed that up. but we have 4 plus 1 over 4. So f of 4 equals 4.25. And so when we look at these three, we look for the smallest and the biggest y value. So we have our minimum, our maximum. So our maximum is going to be at, so 0.2 produces the largest y value. So our max is at the coordinate 0.2, 5.2. And then our minimum, we look back, our smallest y value is produced from f of 1. So then we have our maximum at the coordinate 1, 2. And those are the two examples from 4.1.